Welcome to this video. In the previous video, we learned about similarity, similar triangles, and basic proportionality of similar triangles. In this video, we will see another interesting example based on AAA criteria for similarity of triangles. PQR, if XY is parallel to QR, and the area of triangle PXY, ABC and PQR are similar, then find the value of QX. In the previous video, we saw that two triangles are said to be similar when their corresponding angles are equal. We know that XY is parallel to QR, and the area of triangle PXY is half the area of triangle PQR. Hence, from equation 1, we can say that the area of similarity of triangles will be twice the area of triangle PXY if the pairs of corresponding angles are the same, and the ratio of the corresponding sides we can say also the same. That XY is parallel to QR, PQ is the transversal. Let's take the angle of some equiangular will be equal to the angle PQR. Can you tell which of these triangles would be if any other angle of triangles PXY and PQR are equal? Absolutely correct. The triangles whose corresponding angles are PXY and triangle PQR angular triangles. P is the common value of the corresponding angles of all triangles will be equal to the angle 60 and 40 degrees respectively. So according to the AAA criteria of similarity of triangles, we can say the triangle PXY and triangle PQR are similar triangles. Or BC and QR, since we know that the ratio of the areas of two similar triangles are all in the ratio to the square of the ratio of their corresponding sides. Hence, from triangles PXY and PQR, if we observe the triangle, the ratio of their areas will be equal to the square of the ratio of their corresponding sides PX and PQ. With the help of equation 1, can you tell the ratio of the corresponding sides of triangles MNO and PQR? We see that by taking the square root of both these two triangles, we get the square root of 2 multiplied by PX is equal to PQ. Since we have to find the value of QX by PQ, then can you tell us how we will write the segment then PX? We see that the ratio of the corresponding sides PX can be written as 2 PQ minus QX. In this way, if we take any two similar triangles, then we see that the corresponding sides are proportional. That the value of QX by PQ is obtained as the square root of 2 minus 1 upon the square root of 2. This activity teaches us about similarity the relationship between the area of similar triangles and their sides. Leads us to the conclusion that if in any two triangles, if the corresponding angles are equal, then their corresponding sides are in the same proportion or ratio. In the previous video, we saw some examples related to area of similar triangles. This criteria of similarity of triangles we will see another interesting example based on this criteria. In the given triangle PQR, if XY is parallel to QR here, and the area of triangle equiangular triangles is half the area of triangle PQR, then find the value of we studied about the AAA criteria for similarity of triangles. In the next video, to the question, we will look at some interesting examples based on this. Welcome to this video. In the previous video, we saw some examples related to area of similar triangles. In this video, we will see another interesting example based on this. In the given triangle PQR, if XY is parallel to QR and the area of triangle PXY is half the area of triangle PQR, then find the value of QX by PQ. According to the question, we know that XY is parallel to QR and the area of triangle PXY is half the area of triangle PQR. Hence, from equation 1, we can say that the area of triangle PQR will be twice the area of triangle PXY. Observing the figure, we can say that XY is parallel to QR, PQ is the transversal, so angle PXY will be equal to the angle PQR. Can you say if any other angle of triangles PXY and PQR are equal? Correct. In triangle PXY and triangle PQR, angle P is the common angle, so angle XPY will be equal to the angle QPR. So according to the AA criteria of similarity of triangles, we can say the triangle PXY and triangle PQR are similar triangles. Since we know that the ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides, hence, from triangles PXY and PQR, we see that the ratio of their areas will be equal to the square of the ratio of their corresponding sides PX and PQ. With the help of equation 1, we see that by taking the square root of both the sides, we get the square root of 2 multiplied by px is equal to pq. Since we have to find the value of qx by pq, then can you tell us how we will write the segment px? Correct answer. Segment px can be written as pq minus qx. On solving this, we can say that the value of qx by pq is obtained as the square root of 2 minus 1 upon the square root of 2. So I hope you would have understood the relationship between the area of similar triangles. Welcome to this video. In the previous video, we studied the AAA and the AA criteria. In this video, we will look at another example based on it. In the given figure, triangles FEC and GDB are congruent and angles 1 and 2 are similar. Show that triangles ADE and ABC are similar triangles. From the question, we know that triangles FEC and GDB are congruent and angles 1 and 2 are equal. Because triangles FEC and GDB are congruent, we know that corresponding sides of congruent triangles are equal, by which we get equation 1. Now if we look at the triangle ADE, we get to know that angles 1 and 2 are the same. You would remember that the sides opposite to the equal angles in a triangle are also equal. Hence, sides AD and AE would be equal. If we find the ratio of equations 1 and 2, then we get equation 3. Equation 3 tells us that the line DE divides the sides AB and AC of triangle ABC into equal ratios. What do you understand from this? According to the inverse of the basic proportionality theorem, we can say that the lines DE and BC are parallel lines, because of which angle 1 is equal to angle 3 and angle 2 is equal to angle 4. Can you tell why? As we know that the angles corresponding to the parallel sides are equal, because of which in triangles ADE and ABC, angles 1 and angle 3 and angles 2 and angle 4 are equal. Hence, by the AA criteria, triangles ADE and ABC become similar. This is what we had to prove. In this video, we saw how to determine if triangles are similar by using the basic proportionality theorem and the AA criteria. I hope that you have understood the AA criteria well.